So let's talk about conditional prediction markets with quantum markets integration and LMSR bonding curves. So let's take a look at how this market works. So for the market to be created, we need a name of the market or the event which is going to happen, and the various tracks of the market, and the resolution. So is the resolution time and the proposer who proposes the market, and then when this input is given, there's a verification which is taken place by Eliza OS, and then resolver chain link is initiated, and then the market starts. And also one thing, a tweet is made by the Eliza OS bot when the market is created, and for market resolution Eliza OS verifies the result, and at the end also Eliza OS makes a tweet, and Chainlink resolves the market with the help of Eliza OS verification. And this is how LMSR bonding curves look. This is different from the linear curve which is used by polymarket. And this is the market info. This is LMSR bonding curve. There's a LMSR cost function which helps us calculate the LMSR buy share rates for buying and selling. And LMSR stands for logarithmic market scoring rule, and there's a reason we are choosing LMSR pricing. It's because there are some benefits over linear and this quadricircle way of bonding curves. Now let's take a look at our market model. So this is quantum markets integrated in conditional prediction markets. So when the market starts, there are multiple tracks T1, T2 and T3 in which you can vote yes, no, and yes, no. And the next is a trader comes to trade, so he takes some currency and gets some credits to trade on this. The difference here is it's a quantum market and not a traditional conditional prediction market. So in quantum markets you can use the credits that you have in all the markets individually. Okay, so you can use X credits for trading in T1 track, all the X credits in T2 track, and all the X credits in T3 track. And the trader too can also do the same by trading all the Y credits in T1 track, T2 track or T3 track. So there are two cases of resolution here. Let's say track 1 wins. Okay, so the yes users of the track 1 obviously get awarded. Now let's talk about how no users are rewarded. So no users are rewarded on the basis of the second highest probability or the first highest probability of the event. In this case, this is the second highest probability because T2's no users are getting rewarded. So this is second highest probability in this case. And in case 2, if T2 becomes true, then obviously T2's yes shares users will be awarded, and the highest probability no shares users will be awarded. So which is T1's no share users. So this is how this market works. Like it's like a wave equation. So these are the wave that you can these are the wave like that happens when you are trading, and after the trade the tracks which were not of much importance decided on the basis of probability are dissolved, and only 2 tracks remain for rewards, that is one of yes track and other is reward for no track. So how are the reward distributed? Like let's say aren't the currencies duplicated? No, actually it's differentiated on the basis of, it's divided on the basis of ratios. Okay, let's say the TX track has yes a certain amount of yes share, like let's say volume. Okay, and based on the trading volumes of these tracks, the final prices are like the final ratio is decided of yes and no uh, shares, and accordingly the rewards are given. Okay, there's a reason why we chose this model, and there's a lot of thinking going on behind this, like game theory. And let's take a look at the contract. Okay, so here is the contract, and one of the like important things in the contract is, so all the functions are implemented. The important thing is here everything is represented in 4 digits. Okay, like 50.00 is represented as 5000. The last 2 digits are after decimal. Okay, you can explore the contract. This is the create market contract for creating contracts, and this is the resolver chain link contract.
Hello, I'm Anuj and I'll be explaining the Eliza integration in our prediction market. So this is the workflow. So basically we have three agents. One is validator, one is a agent which is handling a Twitter bot, and one is resolver. Okay. So initial user gives a new market request. It goes to the validator and it checks whether it's actually a valid market or not. It should not be spam. It should not be there are several conditions for this. Okay. Uh, Next, it goes to the Twitter agent. The Twitter post the new market, and then it goes to the contracts logic. From there, when the deadline is passed, it goes to the resolver, which currently it's doing a web search to identify which is uh, the winning market, and then it goes back to the contracts and reward respectively. And also it goes to the Twitter bot to post the final results as well. So I'll give a short demo of both of all three agents. So for demonstration, I'm not initializing the Twitter bot. I'm just initializing the validator and the resolver ones. Okay. So the validator is running on the validator is running on 4000 port and the resolver is 4002. Uh, Let me just remove the Twitter bot so that it won't go anywhere. So this is a test file I've created. Uh, let's just so it's connecting to the validator agent. So it will basically give you true or false depending upon if the market is a valid market or not, and a response as well. It says why it thinks so. Yeah, currently it's giving error to generating to the Twitter because I have not initialized that. So yeah, moving to the resolver agent. Uh, so yeah, it usually gives the index of the responses which it thinks is the correct one. Yeah, right now for future events, it's just guessing what could be the correct answer using its model. Yeah. So yeah, so that's it. You can see it gives a few responses depending upon what it thinks is the correct answer.
let's take a look at our freedom of prediction. So this is our market creator contact. We just have to put this here and market will be created. I've already created one, so let's go and here. First, take some currency with which we can trade. So in this market there are so many functions, because you can check any stats of anything whatever you want, which will make your trade better. So this guy buys this shares, yes shares of RCB and no shares of the other two, and this guy is a noob and he buys yes shares of this and no shares of yes shares of 2 and no shares of 1. Okay, so this guy bought okay, no shares of this. You can track whatever information you want from here, calculate yes share price, no share price, whatever you want. Okay, so how much time we have left? Can we still place a trade? No, we cannot, because the time has ended. Now we'll have to resolve the market. Okay, so this market has been resolved. Now we can withdraw the funds, like let's say track ones, we get track ones no shares, track these yes shares, this guy gets ideally nothing because he voted for all the wrong shares. Yep. And one of these tracks has been dissolved, and the track which dissolved was my only two tracks were considered as NCS and RCB. So this